Hello. In this presentation, we'll be going over Group 18's Spring 2022 capstone project that was for Snap-on's manual welding fixture design project.
The motivations for this project are difficulties in Snap-on's manual fixturing process for welding large centric drawers on their toolbox production line. In the current state, issues include this being a two-person operation with poor ergonomics and limited production. It is also a very labor-intensive process for operators. Our team's objective was thus to design a welding fixture to alleviate these problems with the current state. This welding fixture should make the process more ergonomically sound and reduce its rating score to less than 4. It will also decrease labor hours by 50% by making this a one-person process. Lastly, the fixture should improve production by reducing the cycle time by 15%.
Looking back to an earlier stage in the project, we analyzed the current state of Snap-on's problem to come up with metrics to base future improvements on. We conducted a cycle time analysis and found an average drawer took 4 minutes to complete, but this number is subject to variation since there are 30 different sizes of drawers. We also knew coming into the project that Snap-on currently produces about 40 of these specialty drawers per week. We also addressed the current state of the ergonomic problem, and we used Tumeki AI software to complete Rula assessments for the manual weld line. As you can see on the left, part of the operation was deemed high risk, which we identified as an objective to decrease this area to a safer level.
For the design methodology of our fixture, we followed a multi-step brainstorming method. First, we all made hand sketches to incorporate major components of functionality and movement into our fixture. From here, we moved to SOLIDWORKS to build a more rough design and concrete solution. In SOLIDWORKS, we were able to incorporate purchased and designed components and test the feasibility with a rough estimate of dimensions. After testing feasibility, we continued to make additional changes and finalize our design that work in Snap-on's manufacturing environment given the provided constraints. For the future state design of our fixture, there were 6 main components necessary to provide optimal functionality and reduce the ergonomic risks of workers. Those components were the rocker arm welder, the centric drawers, the drawer mount, a tilt table, a track system, and a scissor lift table. All these components as a system provided the necessary degrees of freedom to complete the welding process.
Some future state design benefits include improving the production capacity. The fixture will reduce the cycle time by 15% from 4 minutes to 3.4 minutes. This reduction will save 24 minutes per shift of pure cycle time. If operators remain on this line, they can produce an extra 7 drawers per shift. The fixture will also reduce labor hours by 50%, which can allow for the worker to be relocated for 80 minutes per shift.
Going over the economic benefits of the implementation of a welding fixture, we found that a fully burdened employee costs $50,000. Since we wish to reduce the number of employees on this operation to 1, and there are 1 employee per shift, we found that it would be an estimated savings of $120,000 a year. The fixture also aims to reduce the number of future injuries by 40%. It also has an increase in productivity by 15%, which equates to around $6,800. The estimated cost of this fixture is going to be around $9,500. And so our calculated return on investments is $120,000 plus that $6,800 minus that $9,500, which will get us a return on investment of around $117,000. This was found with the Tumeki return on investments calculator, where you could input the reduction in injuries, increase in productivity, annual savings, and get a solid number.